Sorry, Liam, we got a little bit late start. All right. Liam is not here today. So this is the recording for him because he's going to be at home watching the recording. Yes. All right. So now, after reviewing all of those rules, I have one more rule. All right. It is that when you draw the diagonal, all right, you are going to separate the triangle or the parallelogram into two congruent triangles, which I thought was kind of obvious. All right, because the opposite sides are congruent and SQ is congruent to SQ. Therefore, the two triangles are congruent by what? You're right. Right, side, side, side. So it's easy to see. All right. So triangle SPQ is congruent to triangle QRS. Everybody's good with that? So again, I feel like if you know these rules right here, you can answer all of the questions today. These are the important things that you need to know. Anybody have any questions with that? All right, you constantly need to refer back if you forget these rules. All right, so now let's look down at the particular problems. All right, so for number one, what does X equal? 30, good. Anybody have any questions with 30? Now, because this is 90, they're all what? They're all 90, all right? So then Y is equal to
90 over 4.
45 halves, very good. All right, anybody have any questions? All right, so now let's look over here. Number two, obviously Y is equal to what? What does Y equal?
Oh, sorry.
Sure, Y is equal to 11. All right, and X was equal to what? 90 divided by 6 today is? Very good. All right, so now let's try number three. All right, now this is actually called a rhombus. For those of you guys who don't know the definition of a rhombus, the rhombus is just a quadrilateral with all sides congruent. All right, so we know that X is equal to what?
2.
And Y is equal to what?
Wait, isn't a square the same thing as a rhombus?
Sometimes.
Sometimes. It's just like, it's like
All right, so for question number 4, all right, the easiest way to do this is to look at consecutive sides or consecutive angles. They add up to what? So we know that X has to be what? 10, and therefore Y is equal to
60.
no.
Well, 40.
40, I believe, is correct. Well, there's lots of ways to figure that out. Consecutive angles are supplementary or opposite angles are congruent. So if X is 10, this would be 120. 120 is equal to 3Y.
It's not the same side.
All right.
Oh my God.
Okay, so for question number 5. All right, so for question number 5. All right, this angle right here. If I was looking at this angle, can I tell me what this angle is? Yeah, we could say that's 55. There's lots of ways of looking at this. All right, those are alternate interior angles.
How do we know they're parallel? Would it be 65?
Because it says they're parallel. It says in the directions. These are parallelograms. So like I said, there's lots of ways to do that. We can say that the angles add up to what? 180. So I have 2Y plus 115 equals 180. So 2y is equal to what? And so y is just 65 over 2. And now if y is 65 over 2, that means this angle here is just going to be what? 65. Thank you, 65. Right. So if that's 65, the opposite angle must be 65. Right. So now we could say 5x is equal to 65. Anybody got any questions with that? All right, here we go. One more dealing with the side. So obviously x is equal to what? And obviously y is equal to? Are we okay with that? If x is 5, that makes that 72 times 5, which is 360. All right. Anybody have any issues with that? Good?
Yeah.
Come on, this is what I was trying to tell some of you. All right. Now's the time. Don't just sit there and write down the answers. Yeah. Do you agree x is 5? These two are equal. So x is 5. So now 5 times 72 is 360. So that means 2y is equal to 360. Okay. All right, here we go. Number 7. Now you have to remember the rule. The diagonals of a parallelogram bisect each other. All right. So for number 7, x is equal to what? And y is equal to what? Thank you. Number 8. Now, it looks to me like if this is a parallelogram and they mark these two congruent, then eventually you'll know that it's a rectangle, but they are all in fact going to be equal. So they're all equal 28. Do we agree with that? So x is equal to what? And y is equal to what?
14.
What's the matter?
Saying that the line is 2y or the angle is 2y.
If it was an angle, they would put a degree mark. All right. Now, this, of course, is a rhombus. Again, special parallelogram, all sides are equal. I'm not sure why this problem is actually here. Because the diagonals of a rhombus are perpendicular, but how would you know that? Is there any way to show that this is, I mean, we would know this is 60 degrees right here.
And then do 60 plus 2x equals 180. But it does move.
But we don't know what this measure is. We don't know. I mean, I know it's 90, but you don't know it's 90. So we know that 2x is equal to 4y, but how is that helpful?
You know, it's 90. Because it's perpendicular, but they didn't tell us that.
Right. I think they accidentally either left something out here or Yeah, so if you want to learn that little rule, I'm not sure there's a way to demonstrate that given the numbers that they have given us. 2x. Oh. Oh, here's what man. All right, I think I might have figured it out. So look here, if I didn't know that, can we agree that this is unknown? So I'm just going to call it Z, right? And then we know that's Z because they're vertical angles, correct? So then we can say that the angles of a triangle add up to what? So then we could say that 2x plus 60, oh, that's not going to help, equals, or plus Z equals, yeah, that's not going to help. Yeah, I don't know how you're supposed to know that. All right, so let's just make sure you know the rule now. The diagonals of a rhombus are perpendicular. All right, the diagonals of a rhombus are perpendicular. So because they are perpendicular, that means this is a 90-degree angle.
That means all of them. And the other ones too.
So what's X going to be?
15.
Well, we know that 2x plus 60 must equal 90, right? So X would be 15.
Wait, why does 2x plus 60 have to equal 9?
Isn't this a 90-degree angle?
Yes.
So that means the other two angles have to add up to 90. And we know this is 60 also. So then we would say 4y plus 60 equals 90. So that means y would equal what?
Why are the two smaller angles equal to the one?
What are you asking? Why are the two smaller angles what? All right, so that one's I need to fix. All right, number 10. So what does X equal?
40. What?
10 what?
Over 3.
10 over 3, right? And what does Y equal? Y equals what? Now, this is a good question. Are they referring to, I think they're looking for this right here. But I think they really wanted it to be the angle. Yeah, it has to be 30. And I need to make a big mistake on this. I need to fix that one too.
No. How did you find Y?
Well, it's 30 degrees. All right, I'm changing it to 30 degrees because this right here, you don't know how to find that right now at the moment. It is, the diagonals bisect each other, right? So this is equal to this. Do you agree with that? No, 3x equal to 10. That's why I do think they made a mistake here and didn't say that should be Y degrees.
Oh, right.
You see what I'm saying? Hello. I'm telling you, it's a side. I agree that you may have thought it was an angle, All right, but it's not, it's a side.
Wait, is y the angle below the right angle?
This angle. is what-
Oh. Okay.
All right, here we go. Now here you have to be real careful because what are they telling you about this angle here and this angle here?
They equal 90.
That's what that says.
Yeah.
They're congruent, correct.
They don't. equal
All right.
90.
They do in fact both add up to 90 because they're telling you that they are congruent.
They both have to be 45.
So X is what? X equals 15, perfect. All right, so that makes this what?
45.
45 degrees. Now, if those are 45, then that makes this a 90-degree, correct? Which means this is 45, do we agree? Which means that if this right here is what? 12, then this right here must also be what? Exactly. Which means this must be 12, right? Does everybody agree with that? Which means this must be 12. Do we agree?
Yeah.
So then we can calculate this by doing what theorem? Right. A squared plus B squared equals C squared. So we have what? So 2 times 144 equals C squared. What's the square root of 144?
Well,
So that is 12 radical 2. Everybody agree with that? How do I know that the two outside lines are 12? You mean, how did I know this was 12 and this was 12?
oh, like on the outside of the board.
Well, they're 45-degree angles, right? So if the angles are congruent, then the sides are congruent. That's an isosceles triangle, right?
Why did we put the two?
Do you agree with that? Okay, what? Yeah, so y is 6 radical 2, right?
How did you get 12 radical 2?
I took the square root of 144.
Wow.
So that's 12 radical 2.
But that didn't. If we take 12 and put it on the outside, then wouldn't it be 14? Because there's already a 2 on the outside.
Where's the 2 on the outside?
Yeah, you moved it inside that.
144 plus 144 is 288. So what's the square root of 288? 2 times 144.
That's the square root.
Square root of 144 is what? That's how I got 12 radical 2.
Why outside sides. It's two.
It's an isosceles triangle, isn't
Just.
it? The angles are both 45. Right?
Yes.
All right, you guys, come on now. Some of you guys are working a little bit harder than others now. All right. These are kind of tricky, trickier than what I thought. Anybody have any problem with 6 radical 2 is the value of y? All right. So this is 17. Do we agree with that?
Oh.
This is a right angle right here. This has to be 4. This has to be X. Yeah, I don't think I can tell anything from this either.
Do A squared plus B squared plus C squared for that, 4 and 17. And then on those ones,
What's the right angle?
there's,
You could do A squared plus B squared equals C squared, the triangle on the left.
X squared, you could do
90
X squared plus Y squared,
Oh, wait, that's an angle.
X 9, X squared.
You are, that was very
plus-
good. That was very, very good. What? Good. I did not hear you say it, or I would say that was a great job. Right, I did not even see that. That was excellent. Whoever's thought is to see that. This right here, now, this right here is 8. This is going to be 15, but we don't know that yet. And this is 17. All right, so you have a right triangle. Very, very good. So from that, we have a squared, which is 8 plus x squared equals 17 squared. 64 plus x squared equals 289. X squared equals 225. So x was what? X is definitely 15. Anybody have a problem with that? That was really good. Anybody have an issue with that? X being 15. Now we have to find y, and we're gonna do it the same way, correct? Except this time it's what? 4 squared plus 15 squared equals y squared.
Where's the 15 squared? Got it.
You just figure it out.
May let's get the square root of 241.
I can't simplify.
Okay. Now here, let's go ahead and understand. Let's just do number 13 real quick. 3, 6. Oh, how much time do we have? Five, 8. Three, -2. So if we were going to find the diagonal here, you don't have to draw this anymore if you don't want, after you realize what we just did. This point right here, if this is equal to this, what is this point called then? Yeah, there you go. Thank you. It's called the midpoint. So you don't have to do that anymore. All right. You don't have to draw it. You just need the midpoint. You need the midpoint of what? Either or. That is correct. All right. So let's just take the midpoint of AC. All right. What's 3 plus 3 divided by 2? And then y plus y divided by 2. 2, right? So if we do AC, and then what happens if we do BD? What are we going to get? 3, 2 also, right? So if for your notes right now, if you want to find the intersection, all right, of the two diagonals of a parallelogram, it's just the midpoint. Okay, yes, sir.
Would you add up and put it over 2 because you're finding the midpoint?
That is the definition of midpoint. The midpoint is you add the x's, divide by 2, add the y's, divide by 2. That's a midpoint formula. All right, so here we go. So now we have a parallelogram ABCD. All right. So let's call it ABCD. We're trying to prove that triangle ABC is congruent to triangle CDA. Statement number 1.
Parallelogram ABCD.
ABCD is a parallelogram. And that's what?
Given.
Given.
Can you just put square? ABCD.
It's not a square.
Parallelogram takes a long time.
All right, that's why I just drew a parallelogram.
Can I just put it in front of the letters?
Okay, now for step number 2, if you have a parallelogram, you always know that AB is congruent to what? And then we can say opposite sides of a parallelogram are congruent. AB is congruent to CD and BC is congruent to AD. So we now know that this is equal to this, and this is equal to this. Now, what do we say? Thank you very much. AC is congruent to AC. And that is. And then for step number 4, we can say.
Triangle ABC is congruent to triangle CDA.
For sides.
Easy, easy, easy. All right, let's get to something a little bit. Yes, sir, Whit.
Why would we draw both diagonal lines?
Because they're asked about triangle ABC. You agree with that now? All right. Let's look here. Parallelogram PQRS with diagonal PR. PR is an angle bisector of QPS. QPS. So that means this is equal to this. And over here, this is equal to this. So why does it have to be 1 tick mark on each? Can anybody tell me? Instead of 2 tick marks?
Because,
Tell me, I'm listening.
because the angles on the left can be different from the angles on the right. So, but they're still the same. I explained that bad.
No, it's okay. Go ahead. Try again.
So it's like the angles on the bottom left are congruent to themselves. The angles on the top right are congruent to themselves. They aren't congruent to each other.
Why not?
So do we agree that the opposite angles of a parallelogram are congruent? So everybody with me on this? All right, this is what we're trying to show you now. I'm just here to tell you there's no way hey, and I mean this for all you guys who just kind of blankly staring, because when you take the test on this, Once again, I don't have everything memorized. All right, everything I do, I kind of reproduce on my own. All right, I don't need to prove them all. I can just look at it and see. Or this is what I'm trying to tell you. We're not going to remember this. All right, but you should be able to figure things out. That's what I'm trying to encourage you to do. What's true about angle P and angle R? They are congruent. So if I bisect both angles, then all of the angles are what? There you go. All of the angles must be congruent. Does everybody agree with that? And if all of the angles are congruent, then what's true about PQ and QR? They are congruent because now you have a what kind of triangle? You have an isosceles triangle. You're not going to remember that. You've got to figure that stuff out. Right? There's no way to remember all these rules. And hopefully you're understanding what I'm saying. All right. I put 2 tick marks because I wasn't even thinking about it. All right. And then I thought, oh, that was kind of dumb because the triangles or angle P is congruent to angle R. Therefore, if you bisect both angles, both of those are congruent to each other. So now I know that this is congruent to this, which means this is congruent to this. So that parallelogram now is a what? Now it's a rhombus. Yes, ma'am. Okay, you sure? All right. That's a rhombus. All right.
Why don't put square?
Is it a square?
It looks like a square.
A square has what kind of angles? A rhombus, someone mentioned earlier, is a tilted square. All right, it's exactly right. It's a tilted square. All right, but if you straighten the sides and make the sides perpendicular, it becomes a what? It becomes a square. Okay, so now let's look at number 17. Let's see if we can see any observations. It says, given parallelogram WPRK with angle bisector KD. All right. So this right here is equal to this. DP is 5. And WD is 7. KR. KR is definitely what? I like that.
We make a line through DR, so there's 3 triangles.
I don't care what you do. You want me to draw DR, you said? All right, so I appreciate the KR was 12. Let's try to figure out what WK is now. All right. So your job, please, lots of practice. All right, finish up. All right, 1 through 31, you're welcome.
Are you like 28 like